Hi. In this video, we are going to look at a few algebra problems. And let's start off with question number 108. And this says the number of three-term geometric progressions comprising distinct natural numbers less than or equal to 200 with common ratio as a natural number. So we have to find the number of three-term geometric progressions which are made up of natural numbers less than or equal to 200, and the common ratio is also a natural number, right? So basically all the three terms here should be natural numbers. So numbers from 1 to 200, and the common ratio should also be a natural number. So we have to count how many such GPs are possible which have three terms, right? So let's say the terms of the GP are A, AR, and AR square. Now here, obviously, R is greater than 1. Why am I saying R is greater than 1? Because the question said that it is a distinct natural numbers present in this GP. So if the natural numbers are distinct, they are not equal to each other, then common ratio cannot be equal to 1. And if common ratio is not 1, it will be greater than 1 because common ratio was also a natural number, right? So now this is the situation, and we want to ensure now that the highest term should be less than equal to 200. AR square is less than equal to 200. So therefore we get A is less than equal to 200 by R square, right? This is the condition, but A, AR and AR square are all natural numbers. And since they are natural numbers, we basically have to count what are the possibilities of A so that A is an integer, right? So A should be something like 200 by R square GIF, because these are the different possibilities of A being an integer. We have put a GIF sign here because that tells us how many possible integers are there. For example, if R is equal to 2, we can say that 200 by R square, which will be 4, which will be 50. GIF of 50 is equal to 50. So basically A could be 50, right? Because you will get 50, 100 and 200, right? And A is less than equal to 50 you are getting, right? So notice that A can be anything less than equal to 50 in that case, if R was 2. So you would get basically so many possible GPs with R as 2. The GPs could be starting with A equals 1, and therefore there are 1, then 2, then 3, till 50, right? So there are 50 possibilities if you get R is equal to 2. Basically, you're getting an inequality on A for every given value of R. So if you take R is equal to 2, you get 50 possibilities. If you take R is equal to 3, you will get A is less than equal to 200 by 9. And that will be basically A is less than equal to 22, right? So A could be 1, 2, 3 till 22. So 22 possibilities. So similarly, if you will take cases for all the different possible values of R, so R can be 2, 3, 4, 5 till 14, because 14 square is 196. And the number of different GPs will depend on the different possibilities of A. Different possible values of A, because A is less than equal to, we are getting 200 by R square. A is less than equal to 200 by R square. So the number of different possibilities of A would be GIF of 200 by R square. This number will count all the different possible values of A starting from 1, right? So our answer will be R goes from 2 to 14 summation of 200 by R square. When R is equal to 2, our answer was 50. 50 possible GPs. Each of them starting from A is equal to 1 or A is equal to 2 up to A is equal to 50. Similarly, for each different R, we get different values. And if you evaluate this, this looks like something like 50 plus 22 plus 12 plus 8 plus 5 plus 4 plus 3 plus 2 plus 2, and then 4 ones will come. The overall answer here comes out to be 112. And there are basically 112 different three-term GPs such that each number is a natural number and common ratio is also a natural number, and the highest number is less than or equal to 200. So I hope you understand how we are getting so many different GPs. The list will be something like this. When R is equal to 2, A can be 1, 2, 3 till 50. When R is equal to 3, A can be 1, 2 till 22. When R is equal to 4, you will get A can be, A is less than equal to 200 by R square, so 16. So this is basically 100 by 8. So this is A is less than equal to 12, right? So A can be 1, 2 till 12. So we are adding up these numbers 50 plus 22 plus 12. These are the different GPs that are possible, right? So that's how we solve this problem. Let's move on to the next question. This is problem 109. And this question says that A1, A2 till A11 are 11 AMs between 1 and 9. G1, G2, G11 are 11 GMs between 1 and 9. So these are 11 arithmetic means inserted between the two numbers 1 and 9. And similarly, G1, G2, G11 are 11 geometric means between the two numbers 1 and 9. And H1, H2, H11 are 11 harmonic means between 1 and 9. We have to evaluate the product. K goes from 1 to 5. AK, G of 12 minus 2K, and H of 12 minus K. So we have to calculate the value of this product. Okay. Fine. So our job is to figure out what is all this AK, 12 minus 2K, H of 12 minus K, and so on, right? So the basic concept here is that if you have 1 and you have inserted 11 AMs, all of these numbers are in AP. These are 13 numbers in AP. So what will be my AK? So think about it. A1 is the second term of this AP. A2 is the third term of this AP. So AK is basically K plus 1th term of the AP, right? So AK is going to be 1 plus K times D, right? And we can find out the common difference of this AP because we know that there are 11 and 2, 13 terms in this AP. And first term is 1, the last term is 9. So 9 is equal to 1 plus 12 times D. So you're getting D is equal to 8 by 12 or 2 by 3. So the common difference is 2 by 3. So we have 1 plus 2K by 3. That is my AK, right? So we have found our AK. AK is coming out to be 2K plus 3 by 3. Okay, great. Similarly, we have to figure out our H of 12 minus K also. So what is H of 12 minus K? We have 1, H1, H2 till H12, H11 and 9. These are in HP. So you'll have 1 by 1, 1 by H1, 1 by H11 and 1 by 9 will be AP. So the common ratio D dash here would be 1 by 9 minus 1 whole thing divided by 12. Again, there are 13 terms. So this becomes minus 8 by 9 by 12. So minus 8 by 9 by 12. So this becomes 2 by 3 and this becomes minus 2 by 27. So this is the common ratio of my HP. And if this is the common ratio of my HP, I can write HK term first. Let's think about the HK term. So similar to the AP situation, the HK term is basically the K plus 1th term of the AP. The AP is made up of the reciprocals, right? So we can say that HK is equal to, the first term is 1 plus K times D dash. And if you realize D dash is minus 2 by 27. So minus 2 by 27 into K. And this is my HK. So what will be H of 12 minus K? That will be 1 minus 2 by 27, 12 minus K, right? So let's think about what this comes out to. 1 minus 24 by 27 plus 2K by 27. So this becomes basically 3 by 27. So it is 2K plus 3 by 27, right? Actually, I have made a mistake here. The mistake is that it is not HK that is this. It is actually 1 over HK that is equal to this, right? Because HK was not in AP, it was 1 over HK terms that were in AP, right? It was harmonic progression. So this is 1 over H of 12 minus K, which is equal to this. So from here, H of 12 minus K will come out to be 27 by 2K plus 3, right? So notice a nice pattern. AK was 2K plus 3 by 3 and H of 12 minus K is 27 by 2K plus 3. So the product of AK and H of 12 minus K, if you want to calculate, we can do that here. Anytime you multiply AK and H of 12 minus K, it will become 2K plus 3 over 3 times 27 by 2K over plus 3. And this gets cancelled and this product is simply 9. AK H of 12 minus K. This product is 9. Now all we have to figure out is what is G of 12 minus 2K, right? So far we have figured out that AK H of 12 minus K is 9 and we have to find G of 12 minus 2K. So again, 1, G1, G2, G11, 9 are in GP and 9 is equal to 1 into common ratio to the power 12 because there are 13 terms. So common ratio is going to be 9 to the power 1 by 12 and that is 3 to the power 1 by 6. That is the common ratio, right? Now from here we can say that GK is the K plus 1th term of the GP. So it will be 1 into R to the power K. So this is going to be 3 power K by 6. That is my GK. So what is G of 12 minus 2K? That is going to be, instead of K, I am putting 12 minus 2K. So 12 minus 2K whole divided by 6. So notice that this is 3 power 2 minus K by 3, right? Okay. So, right. This is what is coming as G of 12 minus 2K. So now all we need to do is figure out different possible values of K and see what is coming from there, right? So the product that we had was K goes from 1 to 5, AK, H of 12 minus K and G of 12 minus 2K, right? So this part is anyway going to be 9 for all of them. So when you do the product, you'll get 9 into 9 into 9 into 9 into 9 for 5 different values of K. And then you're left with product of K goes from 1 to 5, G of 12 minus 2K, right? Okay, so this product is basically G of 10, G of 8, G of 6, G of 4, and G of 2. That is the product. And if you put K values, so notice that actually we didn't need to find this. We can just use G of K directly, right? So this is 3 power K by 6. So you have 3 power 10 by 6, 3 power 8 by 6, 3 power 6 by 6, 3 power 4 by 6, and 3 power 2 by 6. So you are going to get 3 power 10 plus 8, 18 plus 6, 24 plus 4, 28 plus 2, 30. 3 power 30 by 6, which is 3 power 5. So the product of all the G's is becoming 3 power 5. And here you already have 9 power 5, which is equal to 3 power 10. And this is 3 power 5. So the answer for our overall question is 3 power 15. Now, this question is not actually very difficult. All you have to do is to know that when you have a situation where you have AMs and GMs and HMs inserted between two numbers, you have to think of the whole sequence of numbers as a AP, GP, or HP. And then use standard knowledge about AP and GP, and that should help you solve it. Okay, let's move on to the next problem. This is problem 110. And here we have to find the value of tan to the power 4 3 pi by 16 minus 4 tan cube 3 pi by 16 minus 6 tan square 3 pi by 16 plus 4 times tan of 3 pi by 16. So we have to find the value of this number. If you think about it, this angle 3 pi by 16 is slightly awkward. What we can do is call it A, and we'll say 3 pi by 16 is A. So from here itself, we can say 4 times A is going to be 3 pi by 4, which is a better angle because now I can take tan here and get tan 4A is equal to tan of 3 pi by 4. And tan of 3 pi by 4 is minus 1. So this can be written as 2 tan 2A by 1 minus tan square 2A is equal to minus 1 using trigonometric formulas. And from here we are getting 2 tan 2A is equal to tan square 2A minus 1. So our equation has become tan square 2A minus 2 tan 2A minus 1 equals 0, right? Now, this equation can be simplified again by expanding tan 2A in this way. So tan 2A is equal to 2 tan A by 1 minus tan square A. So what we'll do is tan square 2A will be 4 tan square A by 1 minus tan square A whole square minus 2 times 2 tan A. So 4 tan A by 1 minus tan square A minus 1 is equal to 0, right? So this is the expression that we are getting right now, and I will try to simplify it a little more now. So let's see what we get then. So simplifying basically this equation, I will take the common denominator 1 minus tan square A whole square, and I will get 4 tan square A minus 4 tan A into 1 minus tan square A minus 1 minus tan square A whole square equals 0. So we are going to get here 4 tan square A minus 4 tan A plus 4 tan power 3A. Then you have a minus 1 minus tan power 4A and a plus 2 tan square A equals 0. So now collecting all the terms, you have a minus tan power 4A and we are getting a 4 tan cube A plus 4 tan cube A. This term, okay, there is a tan square A term, so plus 6 tan square A is there from here and here. Correct. So this term is gone, and then you have minus 4 tan A is equal to 1, right? And now multiplying the whole thing with minus 1, you get tan power 4A minus 4 tan cube A minus 6 tan square A plus 4 tan A is equal to minus 1. And here our A value was 3 pi by 16. So basically we have figured out this whole expansion. And it comes by thinking of the angles and doing double angles twice, right? Double angle formula we use so that we could simplify this expression in a nice way using the tan 2A result, right? So that finishes off this problem. Uh, I hope you are understanding what we have done in these problems. If you like the video, please subscribe to the channel, share it with your friends. I would love to have all your support as we try to bring more content for JEE Advanced and Olympiads. I'll see you next time. That's it for this video.